In this chapter, we will be looking at trigonometric functions and identities. In this lesson, we're going to look specifically at the transformations of sinusoidal functions.
Okay, hi everybody. So we're going to take a look at the transformations of sinusoidal functions. And you're going to see that the transformations of sinusoidal functions are basically the same as the transformations of any function. So first of all, we're going to take up the vertical displacement. Okay, that is simply the vertical translation. Okay, we're just using a slightly different bit of vocabulary here, but it's going to be the d value in both cases. And so that's going to be responsible for moving things up or down. Okay. We're using a slightly different vocabulary here, mostly because of the applications that you see a lot of the trig functions get used in. This is just a commonly used phrase for that. The midline or median, okay, is going to be the middle of the graph here, and that is going to again be the d value here. Okay, think about it like this: if you just got a y equals the sine of theta there, it's the horizontal line that runs through the middle of it would be the x-axis, and so we're going to move that up or down by adding d to it, and so that's going to become the midline there. So what's going to happen here is we're going to have this equation here, this line y equals d, and that is going to be the equation of the midline, or the horizontal line cutting it in half here. And so you can see down here, and if d is greater than 0, it's going to move up. If it's less than 0, it's going to move down. And if you know the max or minimum values, okay, it's just the average of the two. We add the max to the min, we divide by 2, that's your median value. And then over here, and this is important for word problems, more specifically, okay, this is where we use this most often here. If you want to figure out what the range is, and it's usually going to be the absolute value. So we're going to take the absolute value of the amplitude, add that to d, or we're going to take the absolute value of the amplitude and subtract that from d. Okay? So here, we can see that our maximum value for this particular graph here is going to be 1. This is our max. Down here, we see our min here at -3. So our median is going to be the d value, which is going to be the sum. It's going to be the max plus the min over 2. And that's going to be -2 over 2 or -1. So we get this median line here at y equals -1. And in fact, if I come over here and just draw a line along y equals -1, you can see that it cuts this graph in half. The amplitude is going to be the max minus the min over 2. So it'll be 4 over 2 or 2. And that's exactly what I'm seeing here. If you take a look at our median line, if you go 2 units up, we get to the maximum, 2 units down, we get to the minimum. Now bear in mind what the scale is. Okay, it's the 2 blocks here. Every 2 blocks is going to be considered 1 unit here. In this case, to figure out our period, I'm just going to take the peak. Okay, I'm going to compare peak to peak, and notice that that is 2 pi. And so if that's 2 pi, b, remember, is going to be 2 pi divided by 2 pi, the period. Okay, 2 pi over the period, and that's just going to equal 1. And our range here, well, we've already established our range is going to be from -3 up to 1, minimum up to the maximum. Okay, so now let's take a quick look at the characteristics of these graphs here. What happens if we take the sine of x plus 3? Okay, well, wait a second. If I start here, 1, 2, I got to do here. So this is going to be my 1, this will be my -1. So my graph kind of has to look like this to start off with. I'm going to graph just the sine of theta right now. And so sine of theta is going to hit a maximum there, minimum at 180, 0 at 180, minimum at 270, and then back up to here. So it's going to go up, down, down, up. Okay, so there's my sine graph. Sine of theta plus 3, what that's going to do is that's going to take the median line and that's going to jump that up to 3. So 1, 2, 3. There's my new median line. So starting here, it's going to go up to a maximum there, down to the median line again, down to a minimum, 1 below, and then back up to the median line. So it's going to go up and then down like that. And so here, this is going to be y equals the sine of theta plus 3. Over here, the cosine of theta minus 2, well, let's take a look at what the cosine of theta looks like. And actually, I think in this case here, I can make my scale a little bit better. Up here, if I'd gone up 3, that would have pushed me right off the graph here. But here, I think I can get away with it. Okay. So cosine should start at its peak. At pi over 2, it's going to be down to 0. At pi, it'll be at its minimum. 3 pi over 2 is back at 0, and 2 pi is up at its maximum, so it's going to go like this. Oh, that didn't look good. And so there's cosine of theta. And now what we're going to do is we're going to drop that down 2. So my median line is going to be now down here at y equals negative 2. And so I'm just going to start and graph the same way here. From at 0, it's going to be up at the top, so it's going to go down here to 0, to the median line, down to its minimum, up to its median line, and then up to its maximum there. So the graph's going to look something like that. And this is y is equal to the cosine of theta minus 2. Whoops, minus 2. Okay, now let's take a look at the characteristics of sine of theta minus c, or cosine of theta minus c. We'll do the same thing here. And when we do this, okay, this horizontal translation we are going to call a phase shift. And again, that's just because of the applications of these functions here that we use this terminology phase shift. So, but you know this. If c is greater than 0, it's going to move to the right. Now, bear in mind, there is a subtraction that's in there. So if you're seeing theta minus, let's say, 2, we know that that means 2 to the right. Okay, because the c value is positive. If you're seeing a positive value in there, then we know that there were 2 negatives. I was subtracting a negative, and then negative means you move to the left. So let's take a quick look at what this is going to look like. And before I do this, I'm going to graph the original here. So sine of theta would simply look like this. Okay, at pi over 2, it's going to hit its maximum. At pi, it's going to be down at 0. At 3 pi over 2, it's going to hit its minimum and then back up to 0 at 2 pi. So it's going to go up, down. That's pretty good, actually, hey? I'm pleased with that. That actually looks really good. And I'm going to come down here. I'm going to go backwards a little bit. So it's going to go down to here and then back up. So it's going to come down and back up. Oh, yeah. Oh, that did pretty good. I'm pleased with myself there. Anyway, so now what we're going to do is we're going to sketch this. Okay, shifted pi over 2 to the left. So that means this point right here, which was at pi over 2, is going to move backwards here. Now, basically, all these points are going to move backwards a quarter function, or a quarter period, which in our case here really means it's going to move backwards three steps. Okay, so now it's going to go up, down. See now, and then I would have pulled a maximum out here to there. It would have gone up to there. And so now it's the red graph here that I've shifted over here. Now, but look at that. Isn't that amazing? That graph, that red graph there, which is sine of theta plus pi over 2, is really the graph of cosine. And I think that's just absolutely amazing. Anyway, now let's take a look at this one over here. We're going to start with cosine, and just like I did before, I'm going to start with a cosine. And cosine's going to start there, and in a quarter, or to pi over 2, it's going to go down to its 0 there. Then it's going to go down to a minimum at negative pi. It's going to go to, well, this is going to be relatively tight here. So it's going to go to 0 here, down to its minimum at pi. 1, 2, 3, 4, 5. It's going to be this line right here. And then 1, 2, 3, 1, 2, 3. And I've given myself some room there, so it's going to go from there. 1, 2, 3, and then 1, 2, 3, right down there. So the graph's going to look something. Oh, that was terrible. Okay, wow, look at that. Oh, so much better when I did it before. Sine graph was way better. Anyway, now we're going to move it. Pi to the right, because the C value here is going to be positive. So now pi here is going to be 1, 2, 3, 4, 5, 6 spaces here. So 1, 2, 3, 4, 5, 6. So this spot is going to move there. This one is going to move 1, 2, 3, 4, 5, 6. Going to move to there. And basically everything is just going to move over 6 here. So 1, 2, 3. So what we're going to see actually is something that's going to look like this. Whoops. 1, 2, 3. The graph is actually going to come down. Oh, I can't believe I just did that. Yeah, that's a little better. But anyway, and there we go. Nowhere near as nice as this one, but there you go. So I shifted it over. So now, when you're combining transformations, okay, here we go, all together. A is your amplitude, and here's your formula for the amplitude. B, okay, is going to be related to period by this formula right here, unless, of course, this is a tan function. If it's tangent, okay, your period is going to be pi divided by the absolute value of B. Okay, tangent has a slightly smaller period. D is going to be the average of the maximum and the minimum values, and the vertical displacement, that's going to be your D value. And then here, and then here's the relationship between D and A and your max and your minimums. Okay, so now let's start looking at some questions. All right, filling in the chart, that's classic. So here we go. I'm just going to run down each of these kind of vertically here. The amplitude is going to be the coefficient of the trig function. So in this case, it's going to be 1, 2. Now don't get thrown off by that. That negative is actually another transformation. It's a reflection. That's not the amplitude. The amplitude here would be 3, just like here the amplitude would be 1. We're going to ignore the negatives when we're being asked what the amplitude is. Period. Well, okay. I look at the B value here. The B value is 1, so my period is going to either be 2 pi or 360, okay? Or 360, except for the fact that because I'm giving you the horizontal phase shift in terms of radians, I'm going to assume that that's supposed to be in radians too, so 2 pi. Here, the B value is 2. Now, notice there's no indication of whether this is radians or degrees. So just to alternate, I'm going to assume that it's supposed to be in degrees. So if this is 2, that means my period is going to be divided by 2. So instead of being 360, it'll be 180. Here, I do have an indication that this is supposed to be in degrees. It's that 30 degrees. So my B value is a half. Dividing 360 by a half is going to be 720 degrees. And then here, I do have an indication that this is supposed to be in radians. So my B value is 2. So once again, just like above here, it's going to be half of that period. So from 2 pi to pi. My horizontal phase shift, that's easy enough to read. It's going to be pi over 4. In this case, it's going to be to the right. Okay, because the C value here is actually positive. There should be a negative there, or a subtraction there. There is no horizontal phase shift. Okay, that addition is happening outside the function, so that's actually vertical, not horizontal. Here, it's going to be 30 degrees to the left, because the actual value of C here will be negative 30 degrees. That's supposed to be subtraction. But here, this is the one that's the trick here. Remember from our transformations chapter, you have to factor out that stretch there before you can identify what the phase shift is here. So this phase shift, that didn't come through very clear. That phase shift, when you take out the 3, is going to be pi over 3. So pi over 3, because it's negative, this is going to be to the right. Okay, because that subtraction is supposed to be there. My vertical displacement here, there is no vertical displacement. Here it's going to be 5 up. Here it's going to be 2 down. And here it's going to be 2 up. And so now my range, well, my D value is 0, my A value is 1. So the range is going to be from 0 minus 1 up to 0 plus 1. Here, my d value is 5, my a value is 2, so it's going to be 5 minus 2 up to 5 plus 2. My d value here is negative 2. My amplitude is 3. I don't worry about the negative there. That has nothing to do with it. So it's going to be negative 2 minus 3 up to negative 2 plus 3. And then here, once again, that negative there has nothing to do with it. What's the value there? The amplitude is 1. So this is going to be 2 minus 1 out to 2 plus 1. That's the range. So this question says, for the following graph, write the equations in the form indicated below and assuming a minimum possible phase shift. Okay, so we're going to have to come up with 4 different equations. So positive sine, negative sine, positive cosine, negative cosine. Now, the difference between all of these graphs here really is going to be the horizontal phase shift, where I consider the starting point of that function to be. But my maximum in every case is going to be 1. My minimum, no matter how I look at it, is negative 5. So as soon as I do that, I know that my a value, which is going to be the maximum minus the minimum over 2, is going to be 3. The d value, which is going to be the maximum plus the minimum over 2, well, that's going to be negative 2. Okay, so right away, just knowing the max and the min, I already know, well, 50% of the problem. I know the a and the d value. If I compare the period here, if I want to figure out the period, I really just have to compare 2 points that are easy for me to identify, and I'm just going to pick peak to peak here. Okay, so now notice, if we take a quick look at this, notice that this peak here is at 2 pi over 3. And I know it's 2 pi over 3 because my value of pi is right here, and there are 3 blocks to getting out to pi. So each one of those is pi over 3. So my peak here is at 2 pi over 3. My other peak here, well, if I'm out here at 5 pi, I'm 1 less than that. So this has got to be 14 pi over 3. And if you're wondering how I got that, I know that 5 pi is going to be 15 pi over 3, and I'm 1 short of that. So now the distance between those two, between 2 pi over 3 and 14 pi over 3, well, I just have to subtract them, and I get 12 pi over 3, which is just 4 pi. So I know that my period is 4 pi. Now, you might have looked at this and jumped to that conclusion a lot quicker. That's okay. Okay, I have to give people an arithmetic way of dealing with this, and so I'm going to identify the x value here, identify the x value there, and just take the difference. But that means that my b value is going to be 2 pi divided by the period, which is 2 pi divided by 4 pi, or 1/2. So now I've got a, d, and b. Now, the rest of this is all about figuring out what your C value is. Now, my advice to you is when you do this, identify where the D is. The D gives me my median, and that's the line that goes right down the middle of this. Okay, there's my D value. And when I do that, that helps me identify a whole series of points here. I've got a point here. I'm going to call that A, B, C. And what I'm doing is I'm going top, middle, bottom. Middle, top, middle, bottom, middle, top. And I'm labeling it A, B, C, D, E, F, G, H, I. So now, the first equation that I want to get to is this sine. Well, I know, particularly if they're making me write A as positive here, I know that this has to be y is equal to 3 sine of 1/2. I don't know. That's the part I don't know. Minus 2. I don't know what the phase shift should be. What I do know is that a positive sine graph, okay, y equals the sine of x, a positive sine graph, if you put a box around it, starts at the middle, goes up, and does something like this. So what I need is I need a starting point where the graph starts at the middle and goes up. Okay, starts at the middle, goes, no, it's not B, starts at the middle and goes up. This is my starting point. And it's one block to the left of the y-axis, so it's been moved 1 pi over 3 to the left. So it's going to be minus negative or positive pi over 3. Okay, that's how I figured that out. It had to be along here. The next one is y is equal to a negative sine graph. So it's going to be negative 3 sine of 1/2. I don't know what the phase shift is supposed to be, minus 2, but everything else is the same here. Well, I know if I've got y is equal to negative sine of x, if you put a box around that, it starts at its center, goes down, up, and then down back to the center. So that's what I'm looking for, a point in the middle where the graph is going down. Well, it could be this one. B is a great starting point for that. But so is F, and F is closer. In fact, how close is F? Well, it's 1, 2, 3, 4. It's 5 pi over 3's to the right. So x minus 5 pi over 3. Now we're going to look at cosine. And the A value is the same. The B value is the same. Don't know what the phase shift is supposed to be yet, but the D value is the same. Now cosine, if I know I'm looking for a cosine here, remember how cosine looks. It starts at the top, drops down, and goes back up. So I'm looking for points that are at the peak. So that's A, E, and I. Now clearly, E is the closest one to the y-axis. Because remember, that's how our phase shift is measured. How far away is something from the y-axis here? Well, E is the closest, and it's 2 units to the left. So it's moved to the left 2 pi over 3's. And now finally, negative cosine. Don't know what the phase shift is supposed to be, but I do know that negative cosine, if you put a box around it, is going to start low, go up, and then drop back down. So I'm looking at points at the bottom, so it's either going to be C or G, and C is clearly the closest one, and it's 1, 2, 3, 4 of those blocks to the left. So to the left, 4 pi over 3's. Oh boy, I hope that makes sense. Okay, so this question says, assume the minimum possible phase shift, write the equation in the form. So it's a sine graph where A is positive. Okay, so let's take a quick look first of all at our max. And our max here is 5, that was easy to read. And our min here is negative 3. So our A value will be 5 minus negative 3 over 2, or 4. Okay, and our D value is going to be 5 plus negative 3 over 2. Okay, and that's going to be 1. Now, I would encourage you at this point, like I said before, to draw that line through the center there. Okay, that kind of that vertical center there. That gives me an idea of where a sine graph might start. Okay, now I'm going to judge the period here. I'm going to pick the peak here. I'm going to judge from this peak to this peak. This peak is up here at 3 pi. This one here is at negative pi. So my period is going to be the difference between those two. So 4 pi. B is going to be 2 pi over the period. So 2 pi over 4 pi, or 1/2 again. And then, so I've now got most of what I need here. I know this is going to be y is equal to, my A value is 4, sine of 1/2 x, I don't know the phase shift quite yet, plus 1. But for a sine graph, I know that it's got to start at the middle and go up. Well, that could be this point, and it could be this point, and those are both equally spaced from the y-axis here. So this could go either way. So what you really have to do is just pick one. Is it going to be 2 pi to the right? Or is it going to be, oh, I can't believe I said that. Oh, I can't believe it. 2 pi to the left, or is it going to be 2 pi to the right? Sorry, left, and this is Right. Eek. Anyway, so just watch out for that right there. But you just got to pick one. Don't necessarily write both. Just pick one. That's more my issue. Okay, I need to know that those are both good answers. So for this question, it says assume the minimum possible phase shift and write the equation in the form cosine where a is greater than 0. So it's a positive cosine. Okay, well, we haven't got a lot of information here. In fact, there's just a little bit here. But our maximum here is going to be, what is that, 9? And our minimum is -3. So our a value, which is going to be max minus min over 2, is going to be 6. And our d value here is going to be the max plus the minimum over 2, or 3. And then, like I said, I would draw that line through the center here. Although in this particular case here, because we're looking for a cosine graph, probably won't make any difference. Now our period. Well, I know that from here to here, that's a half period. From a minimum to a maximum is a half period. I also can tell that each one of these blocks, well, pi is right here, and from the y-axis over, that's 1, 2, 3, 4. So each one of those blocks is pi over 4. To go from here to here, that's 1, 2, 3, 4, 5, 6, 7, 8. So the half period is 8 blocks, which means a full period is going to be 16 blocks. And so 16 times pi over 4 is going to be 4 pi. So b, and we've seen this before, is going to be 2 pi over the period 4 pi. So once again, b is equal to a half. Now it's not always a half. It's just in this particular lesson it has frequently been a half. Okay, now I know those guys right there. So this is going to be y is equal to 6 cosine of 1/2 x, I don't know the phase shift yet, plus 3. Now, cosine starts at the peak. Well, how far over is that from the y-axis here? It's 1, 2, 3, 4, 5. Well, it's 5 blocks over to the right, so it's going to be minus 5 pi over 4. And that's how you determine that equation. Okay, this question here says, assume the minimum possible phase shift, write the equation in the form with cosine, but this time where cosine is less than 0. But we start the same place here. Maximum is 5. Our minimum here is going to be -1, yep. So a is going to be max minus min over 2. So it's going to be 3. Our d value is going to be max plus min over 2. And that's going to be 2. And I'll draw that line in the center there, just to help me out here. Y equals 2. My period. Well, actually, I can read this off right nicely, because to go from a minimum all the way up, down, back to a minimum again, my period here is going to be 2 pi over 3. And so b is going to equal 2 pi over the period, or 2 pi over 2 pi over 3. Which means my b value is going to be a nice 3. I like that. So now my cosine graph, where the a value is less than 0, is going to be -3 cosine of 1/2, don't know my phase shift, plus 2. Now, a negative cosine starts at its lowest value here. So it's going to start right there, and that is already on the y-axis. It hasn't been moved. So really, that's my equation. I don't have to write anything in there. There hasn't been a horizontal phase shift. That's it. I'm done. Okay, so this question says, determine the equation of the sine function with an amplitude of 3. The max is at negative pi over 2, 5. Okay, so negative pi over 2, 1, 2, 3, 4, 5. So negative pi over 2, 5. It's right there. There's my max. And the nearest maximum to the right is at 3 pi over 2, 5. Okay, so 3 pi over 2, 1, 2, 3, is going to be over here, 5. Now, halfway in between those two is where I'm going to hit my minimum. Well, first of all, my amplitude is 3, But right away, I can tell you what my D value is. Okay, my maximum is 5 here, so my amplitude, or my median, I should say, is going to be 3 down from that. 1, 2, 3. So here's my line. That's my D line, and so D, I can tell, is going to be 2. Now, the bottom of my graph here is going to be halfway in between. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Did I count that out right? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So it's going to be 6 over 1, 2, 3, 4, 5, 6. And it's going to be 3 down from here. 1, 2, 3. So here's my minimum. Okay? So I can draw this out here because if it's 6 units this way, then to the middle here it's going to be 3. So the graph is actually going to go 1, 2, 3. It's going to look like this. Has to look like that. Amplitude is 3. The D value is 2. My period, well, to go from max to max, the period is simply going to be the difference between those two x values. So that's going to be 4 pi over 2, or 2 pi, which means my B value at 2 pi over 2 pi is going to equal 1. Well, that's kind of nice. Nice little regular old period there. Nothing's been changed. Now what I'm missing is my phase shift. Now, I'm looking for a sine function. Okay? So I want this to be y equals the sine, 3 times the sine of, it's going to be my phase shift, because my horizontal stretch is just going to be 1, plus 2. Well, I know, okay, that if I was to walk this one backwards here, it'd be 1, 2, 3. This graph is going to come back down to here. This could be a starting point for a sine graph, and so could that. But it could be negative pi or pi. They're both the same distance away here, so this could be pi to the left. This could be pi to the right. Both of those are going to give me the same graph. You just got to pick which one that you want to do. And this question says, determine the equation of the sine graph with a minimum at negative pi 2. Okay, so negative pi 2 right there. And the nearest maximum to the right is at 0, 6. 1, 2, 3. Okay. So, and there are 1, 2, 3, 4, 5, 6 in between there. Okay. And vertically, now, sorry, I should do it like this first of all. I know that my max is going to be at 6. My min is at 2. So my A value is going to be 6 minus 2 over 2, or 2. And my D value is going to be 6 plus 2 over 2, or 4. So I'm going to draw a line through at 4. So 1, 2, 3, 4. So it's going to be right here. There's my middle. And I know that since these are 6 units apart here, 3 units away from this minimum, I'm going to hit the middle. Then another 3 units, I'm going to hit the maximum. 1, 2, 3, I'm going to hit the middle again. 2, 3, I'm going to hit my minimum. Or sorry, I should have said 0. I'm going to hit my 0 point here, then 3 more, I'm going to hit my minimum. And so I'm looking for my sine function. Well, what's my period here? Well, to go from negative pi to pi, from minimum to minimum, well, that's a period of 2 pi. I can read that actually quite easily right off the graph, which means my B value, and I just saw this in a previous question, must be 1. So y is equal to 2 sine of, well, the phase shift, the stretch here was just by a factor of 1, so it's going to stay like that, plus 4. So now the question is, what's my phase shift? Well, look along the green line here, the median line. Which of those 2 points is a good starting point for sine? And it's this one right here, because that's where we hit the middle and it's going up. Now, if it's negative pi to get here, then it's going to be negative pi over 2 here, which means this had moved pi over 2 to the left. And that's how you answer that question.